Hello, I wanted to do a special little section with some problem solving, and so this goes along with the material from Monday class on balancing redox equations and sort of our review of what we covered back in chapter 5. So I want to start out with just doing a simple predicting or assigning of oxidation states. So let's just say we have the reaction of calcium, metal, plus water goes to calcium hydroxide plus H2 gas. And we want to assign the oxidation states and predict what is being oxidized and reduced. So first thing is to use our rules, right? So calcium is a metal, an element, right? So it's going to get an oxidation state of 0. If we go over here to the water, so if we remember in compounds that hydrogen is going to be a positive 1 and oxygen is a negative 2. We go over to our products. We look at, again, in some of these more complex ones, it can sometimes be useful to list them out. So I'm going to list calcium. Now I have two OHs, so I have two oxygens, two hydrogens. Now remember, all of these have to add up to 0 because this is a neutral compound. So we know from our rules, right, that hydrogen is going to be a plus 1, oxygen is going to be a minus 2, so each of those. So if I add these up now, I have a negative 4, positive 2, I have a negative 2, so that means the calcium, not surprising, is a positive 2 to make everything add up to 0. Right, so we end up with a positive 2, negative 2, and a positive 1. And hydrogen, again, this is an elemental form, so it's going to have an oxidation state of 0. So now that we've assigned them, we can look for changes. So we can first easily see that calcium goes from 0 to positive 2. Now, that's an increase in oxidation state, so a more positive oxidation state, which would indicate the losing of electrons or the oxidation. Right, so calcium is undergoing the oxidation. Now, if we look for other changes, so notice oxygen doesn't change, right? It's negative 2 and negative 2. Hydrogen is positive 1. Now, there's positive 1, but there's also some hydrogen that has gone to 0, right? So some of our hydrogen has gone from a positive 1 to a 0, or it's getting more negative, right? It's getting smaller, indicating a reduction. So what this is all telling me is that calcium is the element undergoing oxidation, and hydrogen is the element undergoing reduction. Now we can go a little bit further here and predict what the oxidizing agent is and what the reducing agent is. So remember, the oxidizing agent contains the element undergoing reduction. So hydrogen is undergoing reduction, so that means the hydrogen is part of the water, so that means my reducing agent, or excuse me, my oxidizing agent, which is causing the reduction, or excuse me, it's causing the oxidation is the water, right? So the water, by the hydrogen being reduced, is causing the oxidation of the calcium. So remember, the agent is always the entire reactant that element is a part of. So water would be considered the oxidizing agent. The reducing agent causes the reduction. So which reactant is causing the reduction? Well, the one that's being oxidized or contains the element being oxidized. In that case, it's the solid. Calcium is my reducing agent, right? Contains the element undergoing oxidation. So that's, just a little review of, using the oxidation states, assigning them, figuring out oxidation and reduction, and the agents. Okay, the second problem that I wanted to do is a balancing of a redox reaction. So I'm going to do one in basic solution since we did one in the notes in acidic solution, just so you can see the difference. And hopefully what you see is that essentially we follow the same process, except for one step we do something additional to convert it to a basic solution. So the first part of our process, right, is always to assign the oxidation states. So if we quickly go through here and assign the oxidation states, so I minus would be a -1, right? Since it's a monatomic ion with a -1 charge. In the permanganate, the oxygen is given a -2. So we have 4 of them, that's a -8. And so the manganese has to be a +7 in order to make all this add up to a -1. On the product side, we have a 0 for I2 because it's elemental. And in MnO2, again, the oxygen is -2. And the manganese has to be +4. Since we have 2 of these, so we got -4. We need this to all add up to 0, so we have a +4. Now, if we then look at what's being changed, right, to buy out our half reactions, so we see that we have iodine going from -1 to 0. Okay. So in other words, it's getting more positive. Okay. So it has to be losing electrons. Right? So my oxidation half reaction is going to be I minus going to I2. So this is my oxidation. Then my reduction would be the MnO4 going to MnO2. Right, the manganese going from a +7 to a +4, gaining those electrons. So we got a reduction. So we're going to now work with these individually and first balance them by mass. So if we start out balancing this one, we need to have 2 iodines on this side to balance it by mass. So that means this is going to become 2 I minus goes to I2. And that's all balanced now. So now if we balance the second one, so the manganese is balanced, we need to balance the oxygen. So remember, we're going to do that by adding oxygens, by adding water. So we're going to have MnO2. We have to add 2 oxygens. So we're going to add 2 waters Now, by adding the 2 waters, we added 4 hydrogens. So that means on this side, remember, we're going to add H+, so we need to add 4 H pluses to this side to balance out the hydrogen, so that we now have 1 manganese, 4 oxygens, 4 hydrogens on each side. So now we have our mass balanced. So now we need to, at this point, convert it to be basic, right? So at this point in our acidic medium, we would have switched and started balancing charges. But notice the presence of the H+, right? The acidic. So what we need to do to turn it into basic, right, is we're going to use hydroxide ion. So we're going to add enough hydroxide ion to both sides to make this reaction neutralize, or to neutralize the H+ ion. So what we're going to do here is we're going to take and add 4 OH minuses to both sides. So we have 4 OH minuses here, but we have to do the same over here. Now, what happens is the OH and the H+ neutralize each other and form water. So if we rewrite this equation now, we have manganese O4, aqueous, plus 4 waters, and on this side we have MnO2 solid plus 2 waters plus 4 hydroxide ions. So notice now, instead of having hydrogen ions, we have hydroxide ions, right? Creating a basic solution. Now, this half reaction is ready to go, except we do need to clean up the water a little bit. So we can get rid of these 2 waters here and turn this into just 2 waters. Right? We don't need to have water showing on both sides of the equation. So now we have our 2 half reactions that we can now balance electronically. So if we take our oxidation half reaction, right, we have a 2- charge on this side, so we need a 2- charge on this side. So we're simply going to rewrite this as as 2I- goes to I2 plus 2 electrons to give us our electronic balance. And then I'm going to go ahead and write it like this, so just sort of compare them. And then if we look at the permanganate, we have a -1 on this side from our 1 permanganate, and on this side we have 4 minus. So that means we need 3 electrons on the reactant side. So we're going to end up with 3 electrons plus permanganate plus 2 waters goes to MnO2 solid plus 4 OH minus aqueous. And notice we have a -4 on both sides. So now we have our 2 electronically balanced agents. And the next step, right, is to make sure that we show the same number of electrons being lost and gained. So here we show a 2 electron loss and a 3 electron gain. Well, of course, that can't work, so we have to come up with the smallest sort of common value that can represent this. And so to make these the same, the easiest way to do that is going to be to multiply this one by 3, this one by 2, to give us 6 electrons. And so we end up with we end up with 6I minus goes to 3I2 plus 6 electrons. And on this side, I'm going to do it in another color just so we can make it stand out. We have 6 electrons plus 2 MnO4 minus plus 4 waters goes to 2 MnO2s plus 8 hydroxides. Okay, so now we have balanced with electrons. So now the last step is to put these together. So of course our electrons cancel out, right? Because over here they're being lost and over here they're being gained. And so if I look at my reactant side, I have 6I minus plus aqueous plus 2 MnO4 minus aqueous plus 4 waters goes to, on the product side, we have 3I2 aqueous plus 2 MnO2 solid plus 8 OH minuses aqueous. And this becomes our balanced redox equation in basic solution, right? The key being the presence of the OH in the end, as opposed to H plus ions, indicating that we're in basic medium. And so remember, we did that right here. We just added a step to, instead of showing a reaction that had H plus, we added OH minuses to both sides to convert it into a reaction that showed hydroxide ions. So that one additional step is needed when we balance in basic as opposed to acidic. Okay, well, if you want more examples, look at some of the ones in the book for both acidic and basic medium, practice problems, etc. Homework will give you some extra practice in balancing these redox equations.